song that's playing on the radio. Let's swing while color lights up your face. Let's sway through the crowd to an empty space. If you say run.
Okay, hello. Today I'm going to be showing you about exponential growth and decay, right? And this is building out the last section we worked on. Believe it or not, this is actually the same equation that we worked on in the last one. I figured if there was an f of x there instead of a y, but that would be the only difference. So y equals a times b to the x, where a is the initial amount and b is the growth factor. Now the change here is that with b, the question is whether it's getting bigger and bigger and bigger, or is it getting smaller and smaller and smaller. And if it's getting bigger and bigger and bigger, then it's exponential growth. And if it's getting smaller and smaller and smaller over time, that's exponential decay. So if I look at b, and right here, where b is greater than 1, that means it's going to keep getting bigger and bigger and bigger. If b is between 0 and 1, then it's exponential decay, all right? And I should actually put a couple quick graphs on here, so let me do that quickly. I'm going to zoom in so I can show you what they look like. So this would be my y-axis, this would be my x-axis, and if this is going like this, that's going to look like exponential growth. If it looked like this, where instead of going up, it's going to be curving back down like this, this would be the other one, exponential decay. So if you see the graph and they ask you which one it is, just look, does it look like the one on the left where it's exponential growth, or is it going down and to the right where it's exponential decay, all right? So that was the first thing I need to show you guys. And the first one, I'm just going to jump right in on some problems here, is determine whether it's exponential growth or decay. And my first problem has the equation y equals 25,600 times 1.5 to the x. So the initial amount, that's the easy thing, that's 25,600 . Now the question is it growth or is it decay? So I'm looking at this right here, the 1.5. Since 1.5 is bigger than 1, it's going to be exponential growth. If that number is less than 1, between 0 and 1 I should say, then it's decay, all right? So it's growth since 1.5 is greater than 1. Okay, and that's it. That's all they asked for on that one. Nice, easy one to start. Number 2, all right, word problem. Has to do with frogs. Population of 200 frogs increases at a rate of 28% annually. How many frogs are there after 5 years? All right, so I'm going to start off. I've got that same equation, y equals a times b to the x, where a is the initial amount and b is the growth rate. Now this one increases, which means we're going to start with that. Actually, let's start with the initial amount since that's nice and easy. The initial amount would be 200, okay, because that's how many frogs you started with. The growth rate, So it has 28%. Now the first thing is we're going to need to go from percent to decimal, all right? So 28%, for those of you that remember, you move the decimal point to the left, which gives you 0.28. Now, here's where it gets a little bit harder in some ways. It's not, the growth rate isn't 0.28 because I also had the other 100% that is going along with it. So you're going to take 1 and I'm going to add the decimal to it, which is 0.28. So my growth rate is actually 1.28. All right, you're either going to be adding 1 or subtracting it from 1, which means my equation is going to be y equals 200 times 1.28 to the x. And the x is going to be the number of years, which means I'm going to plug in 5 because that's the amount of time right here is 5 years. So I got y equals 200 times 1.28 to the 5th power. And now you're going to want to have a calculator for this. It'd be a painful thing to do that without one. If I take 1.28 to the 5th power, that gives me 3.05. And then I'm going to multiply that by 200 to get my answer, okay? That's a 5 here, clean that up. Equals 610.35. So we'll round that off and say you had 610 frogs, okay? I'm not sure what 0.35 frogs looks like. We don't have to worry about it either. All right, so that's the answer. Next one. A population of a city is 50,000 and decreases by 4% each year. If the trend continues, how many people will be left after 15 years? All right, so once again, same equation. Y equals A times B to the x power. And I'm going to need to know the initial amount and the growth rate. We're going to start with the initial amount first. That one's easier. That's right here in my word problem. The population, which is 50,000 to start. Now the growth rate, this one's different than the last one because the last one said it was increasing, but this one says it's decreasing by 4%. So once again, I need to switch that from percent to decimal. So 4% is going to be, so if I take the 4, move the decimal point 1 to the left, I get 0.04. All right, so 4% is 0.04, not 0.4. 0.4 would be 40%. All right, so the growth, it's actually decay. I should write decay factor, or it's still the growth. I mean, it's just getting less and less. So the decay factor. Now, there's two ways you can do this. Last time we took since it increased, we took 1 and added to it. This time I'm going to subtract 0.04 because it's getting less and less, which leaves me with 0.96. The other way you could think about it is if it's going down by 4%, that means how much of the population is really left, which would be 96%, right? There's 100% out of the whole amount. And if it's going down 4%, that means there's 96% left, which would give you 0.96. That's the other way to think about it. So you could either, do it that way, or you could keep going, I kind of like this 1, if it's growing, it's 1 plus the decimal. If it's getting less and less, decaying, it's 1 minus the amount. All right, either way, you should be able to do one way or the other. Okay, so back to this. Let me write my equation. I got y equals the initial amount is 50,000 times the growth factor, which we said is 0.96, to the x. So that's my equation. And then what I need to plug in for x is 15, because that's the amount of time, which will be 15 years. All right, so now if I plug that in, I get y equals 50,000 times 0.96 to the 15th power. I'm going to punch that all in my calculator, and I'm going to get my answer. So let me do that first. Oh, just one other thing. When I do this in my calculator, 0.96 exponent button on this calculator, the exponent button is y to the x. Sometimes it'll look like that. But anyway, if I take that to the 15th power and hit equals, I'm going to write down that it's, 0.542, but it's really a long decimal, and I'll just leave it in my calculator. I don't usually go clearing it out, okay? So if I go y equals 50,000 times 0.542, but I just leave it in there, and then I multiply by 50,000. I get the most exact answer. And sometimes it will round it off some. It will make a difference depending on how much you round off. So I got 27,104. And I think that was people since it was a city. And that's the answer. Okay? All right, so that's that problem. This one is going to be a U try. Same kind of thing. Population of a city is 100,000 people, and it decreases by 15% each year. A, write a function that models the population growth or decay. So that's your equation, the y equals a times b to the x, except fill in the numbers. And then part B is how many people will be left there after 8 years. Okay, so hit pause, solve that out, and then come back. And all right, welcome back. So if I do this out, the population is 100,000, so I get y equals 100,000. So if it's 15%, that's 0.15, and it's going down, so that's 1 minus 0.15, which is 0.85. So that's going to be my decay amount, or growth amount. 0.85 to the x. So that's actually it right there for part A. You could circle that. That's your answer. Now the part you're going to do down here is you're going to take that same equation, but this time they want to know at the end of 8 years how many people will there be. So you plug in the 8 for the x. Once again, I'm going to take my calculator, 0.85 to the 8th power, do that first, and then multiply by the initial amount. I didn't write this down correctly. I missed some zeros.
Yo, this is Chef Whitey coming in. We're selling truffles tomorrow.
Sorry for that interruption. All right, and so I get 0.27, and then you multiply that times the 100,000, and you get 27,249. And that would be your answer, and that's in people. All right. So that should be my last problem here. Yes, it is. You guys have a great night. See you all soon.